artificial intelligence. We objectively assess the importance of this topic. However, there is still no consensus on whether all tasks can be solved using these technologies. Abuse or obligatory use. We will raise such issues of ethics, modern information society, and cybernetics. This is the story of our virtual conference on pattern recognition and information processing in 2021, which has already begun. Here, right now.
So, we're coming back to our studio, and now we have a chairman in our studio, my colleague, Professor Alexander Nechval, and he will moderate the next session. And I'm kindly advise you to follow our YouTube channel and to ask questions in the virtual platform, in the YouTube channel, in Telegram channel, as well as make posts about our event, whatever you like, using hashtags PRIP, hashtag PRIP'2021, hashtag PRIP'2021 online. Now, you have a floor, and we have a social distance now, yeah?
Okay.
Okay.
Hello, friends. Hello, my colleagues. I'm glad to see you in this section. This last section in our conference. No, not last, sorry. But of course, today we have many interesting reports about different topics. And now we start from a report about interactive error pattern library, formulation methods for the decoding of product codes. Hoffen, Jan Ma, Konopelko, Valery, and Tsviatkou Victor. Please switch your report.
Hello. Hello, can you hear me?
Yes.
Yes, of course.
Can you see my presentation?
Yes. Start.
The title of my presentation is Iterative Error Patterns Library Formation Method for the Decoding of Product Codes. Product codes, which can be easily realized by concatenating simple components codes, have a good protection capability against both random and burst errors. They are formed in the verification code C1 and C2 for the rows and columns of the source code matrix N1 times N2, respectively, where N is the length of the code word, K is the number of information symbols, D is the distance of the code. The random error detecting and the random error correcting capabilities of code are determined by its minimum distance domain, and they have the following relationships. In other words, the product code has capable of correcting a combination of errors T equals D1 times D2 and then divided by 2. The product code is encoded in 2 steps. A message of K1 times K2 information symbols is first arranged as shown in the upper left corner of Figure 1. At the first step of encoding, each row of the information array is encoded into a code word in C1. This row encoding results in an array of K2 rows and N1 columns, as shown in the upper part. At the second step of encoding, each of the columns of the array formed at the first encoding step is encoded into a code word in C2. This results in a code array of N2 rows and N1 columns. This code array also can be formed by first performing the column encoding and then the row encoding. Transmission can be carried out either columns by columns or row by rows. product codes whose components codes are Hamming or extended Hamming product codes, for example, BCH product codes. BCH product codes can be constructed to improve error correction capability, but a more complex decoding process is required. To reduce the decoding complexity of BCH product codes based on the three-stage schedule, a single norm method based on library matching of error patterns is proposed. It can fast match the target pattern from the pattern library by using the norm, which is calculated based on the result of the synonym vector, can uniquely determine the base pattern and the corresponding set of error patterns, and then applied a predefined correction method to correct the errors. The diagram of the whole decoding process is presented in Figure 2. In the schedule of normal decoding product codes, the synonyms and the normals of rows and columns are first calculated. Then, these two parameters can match with a unique error pattern in the library. But before match operation, it's useful to shorten the search error by calculating the rough number of the error. After the matching operations, we will correct the error by a specified correct method. The decoding ability of a single normal method is wholly dependent on the error pattern library. Therefore, one of the limitations of this method is that the formation of the matching library is very time-consuming, so it is tough to form a pattern with a lot of errors. The pattern library applied in the single normal can be present as a set of matrices MRN. Each element in this set should satisfy the following equations. Like that. We have compared our formation method with two known methods, the rec method and the subclassifier method. The rec method first enumerates all the possibilities of error patterns in a given size. This pattern set is named as original error pattern set. Then it compares all these patterns to select some patterns with distinct feature vector to add to the library. The feature vector used in this method including the rec of the matrix. The subclassified method tends to first categorize the original pattern set into several subsets according to some criterion, then conduct the comparison in a smaller set rather than directly compare them with each other. In order to further decrease the time consuming, we have proposed an iterative error pattern library formation method. The mathematical model is presented in the following. Based on these formulas, the following algorithm is proposed for expanding error patterns and adding one error to the element. Figure 3 shows the block diagram of the proposed method. It can be seen that a new set of error patterns can be obtained based on the former set of error patterns. Go through a series of expanding operations and selecting operations. By contrast with other generating methods, the search range of representative error patterns of the proposed is less, which may reduce the time for creating the whole library. The comparison of the computation speed is conducted on the basis of the implement of the three different information methods. The platform of the parent environment in MATLAB under the Windows 10 operation system. The average execution time for generating the error patterns library used by the different methods is summarized in Table 1. We can see from the table that when the number of errors is below 5, all three methods can generate a corresponding library within 1 second. However, when the number of errors is surpassed 5, there emerge some differences. The subclassified method costs lower time by comparing with the rec method, but it also needs 8 minutes to form a library when t is equal 6. is convinced that the proposed method has a better performance in terms of processing speed when comparison. Next, we are shows conclusion. The proposed method differs from the known RAG method as a subclass method by it adopts an iterative forming method to build a number of error patterns. The experiments have proved that the proposed method is a very efficient method, which requires less time to build a same number that formed by the RAG method by the subclassified method, because the proposed method caters to enumerate all the permutation of the possible error situation. The result of the proposed method can be applied in the same normal method, which is a decoding method based on the number matching. In the future, we would like to analyze these patterns in the library, and for each pattern, we will construct a corresponding correction method, then conducting a comprehensive comparison with the famous method. Another interesting direction is explore the performance of the same normal method. Thank you for your attention.
Thank you. Thank you for interesting report, too many schemes, and of course, I hope that your library will be free, and we will use it in our future. Maybe anybody have a question?
I already wrote down the question. Could you please read, or it's necessary to pronounce it? What kind of channel you have considered, and how you have chosen the parameters of product codes?
We use BCH product code. We use a BCH code.
Valery Hockwingham, I think you consider. But what kind of channel you have used? What kind of channel you try to leverage the number of errors? Is it the Gaussian channel, or it's the
Gaussian channel? Yes.
So, have you any experiments, simulation experiments? How you have proved the efficiency of the product code?
Now we only formation the error patterns, and in the future we will use the error pattern to correct the random errors.
So, as you know, there are plenty of different error correcting codes that already exist, like the LDPC, turbo codes, etc. So, what is your construction is better, or have you compared with known codes?
Linear block code, we use BCH linear block code to confirm the product code, two-dimensional product code.
So I think that the future work could be the comparison of different approaches and also the simulation results that you have to consider.
Now, in the future, we will do this experiment to show our result for the normal syndrome decoding of two-dimensional product code.
Okay. Also consider the application, the possible application. Is it the communication channel, or it is the channel of the pattern recognition channel, or something else? So you can consider the practical example. Thank you for your presentation.
Thank you.
A good research.
Okay, we have discussion, but maybe you have any question else? No question? Okay, let's go. We can go to next report. our next report is innovative technology of computing shortest lengths and equal times confidence intervals in reliability and safety under parametric and Tati, sorry for sorry for such bad representation, because maybe I don't see very small letters. After it's Nicholas Nechval, Gundars, Berzins, Konstantin Nechval, Max Moldovan, Vadims, Danovics, and Irina Bausova. I'm sorry if I make mistake in the name, because maybe I don't see text, sorry. Please, if you're ready, please start it. Are you ready?
Well, I'm not sure we have these speakers, so please, we can't read your names now, because not all of speakers signed their names in the visual platform. Yeah, well, probably we haven't these speakers currently, next. Unfortunately. So I hope they will come. Yeah. We should jump to the next presentation.
Okay. Our next report. Yeah, I'm very glad to represent next reporter, because it is Igor Zakharov from Canada. It's very interesting report, and I hope we will listen to many interesting now. The topics of report, it's blockchain system review and analysis for information security of big data. Igor, I'm glad to see you. Please start.
Hello, my dear colleagues. My name is Igor Zakharov, and I'm very glad to see all of you, especially those who are in the wonderful city of Minsk. I would like to present our preliminary results on blockchain systems review and analysis for information security of big data. This work has been recently started at SICOR, which is a Canadian research and development company, and it is conducted in a partnership with Memorial University team, represented here by an expert, just I will share you, in data security and information security by Professor Jonathan Anderson. So do you see our presentation?
Yes, we can see. Thank you.
That's great. Thank you. So there are several important deliverables that we achieved in our blockchain project at this moment. One of the objectives was to understand what is a blockchain, how it works, how it's applicable to big data and other applications, and what benefits it can bring to us. Blockchain business is booming right now. Therefore, this work is important to find everything about blockchains, to be an expert who understand blockchain technologies and all essential system components and their performances. There are many definitions of big data: volume, velocity, variety, etc. For me, it means first that it's such huge volume of data and very high number of files, which are difficult to handle with a modern data center. When you look at the slide, you may recognize on the left a punch card used before 80s last century. 1 gigabyte of data, which typically large image, would take about 10 million such cards. That probably can be considered as big data at that time. Current data centers can store and analyze petabytes of data, and some of them even exabyte scale using cloud technologies. And this is in 1 billion times more than 1 gigabyte of data. The rapid growth of data in the past 20 years can be explained by significant advances in sensors and mobile technologies, emerging Internet of Things and artificial intelligence, and growth of social and entertainment media. Also, blockchains find applications in all of these areas and even more. In our presentation, we will use a healthcare as an example to explain some of technological aspects to see potential of blockchains. Here you can see sources of big data in healthcare. Blockchain can facilitate many of these applications and, for example, secure transfer of patient medical records, manage the medicine supply chain, and helps healthcare researchers. On this slide, you can see current applications of blockchains in healthcare, representing blockchain as service when clients pay for using blockchain platform, data as service to manage medical data flow, analytics, etc. The paper, which will be published in conference proceeding, provides a review of different blockchains, and also it reviews already existing scientific surveys. These surveys analyze blockchain systems, concept, architecture, components, and implementation, focusing on its different applications, including Internet of Things, healthcare, etc. We have found about 20 surveys. Most of surveys are comprehensive and include from 150 to 270 references, which is a lot. Searching Internet, you will find many information on different blockchains, and some of them are related about cryptocurrencies. We comprehensively reviewed and analyzed existing technologies and information available on web pages of different companies which develop blockchain technologies. It helped better understanding trends and changes. You can see the list of blockchains in the table. In total, we found more than 70 blockchains, but some of them already depreciated and not available. So currently we have 61 items. In this table, unfortunately, it couldn't fit in our proceeding pages because it's only 4 pages proceeding paper, but it's very valuable, and some internet resources provides lists of blockchains, but they twice less than we have. In addition, our review includes application, technology, what's used for developing this particular blockchain, availability of documentation and web page. And I would like to provide a short summary of this review. So Java is the most popular language for blockchain. Solidity is a popular programming language for smart contracts. And 14 blockchains were identified as good candidates for big data. So next part of the presentation would be about blockchain system. I want to inform you that blockchain technology has specific terminology, which can make it understanding not so easy from first time. But in reality, blockchains is very simple concept. And I think after this presentation, you will be experts. One of the key words is ledger, which is an account book of final entry to record business transaction. Ledger is also known to be used in real estate and other domains where you need to record information in immutable manner, which means without possibility to be changed. Please see the earlier diagram represents sets of distributed database. It's such database which don't have master storage and is distributed across the network nodes. And subset is a distributed ledger technologies. Blockchain is a subset of distributed ledger technologies, and permissioned blockchains, which require authorization, is a subset of general blockchains. On this flow block diagram on the right, you can see that blockchain highlighted by red rectangular is only one representative of distributed ledger technologies, along with directed acyclic graph, etc. Here you can see an example of distributed ledger nodes connected within peer-to-peer network when each node is connected to other node. You may ask, is it reliable if one node or part of the network is failed or become not trustworthy, not honest, for example, due to hacker attack or something else? The Venn diagram on the right illustrates the CAP theorem, which states that a distributed database system can only have two of the three important characteristics: consistency, availability, and partition tolerance. Consistency means that each node sees the same data at the same time. Availability means that all clients can always find at least one copy of the requested data. And partition tolerance is the ability to system continue operating normally in the presence of network partitions, even if there is network outage or maintenance. CAP theorem is necessary for distributed database, and this is actually a fundamental problem and can be an interesting topic for research on how to optimize all these three characteristics with the distributed ledger technology that can be used to meet strict requirements, ensure transaction, simultaneous data access, validation, record updating, and storing in an immutable manner. Information such as transactions in blockchain are recorded with an immutable cryptographic signature such as fingerprint called a hash. A hash function is a process that takes data of any size and converts it into a unique ciphertext of specific length. As input, it can be text, image, or video. For example, we have a message here as input, and we execute secure hash algorithms SHA-256, which is very popular in blockchains and other applications. And we have output hashed value. So variable properties of the good algorithms, because there are many of them, you will see, it's a deterministics. So it means every time you execute hash function with the same input, you will have the same output. One-way cryptographic functions means irreversible. So when you have output, you cannot restore input message. And diffusion, I will demonstrate how it works. If you make a small changes in the message, for example, we remove a space between PRIP and 2021. Please look what's happened with output. You see, it's changed dramatically, completely. It's called avalanche effect. So you can see the speed performance of different hashing algorithms. SHA-256 has performed 0.4 gigabyte per second on a good powerful computer. We conducted experiments with real images of 1 gigabyte size, and the speed was in more than 10 times or even slower on similar type of computers, because you need to access data from the memory, etc. The best algorithms, for example, XXH3, perform in 40 times faster than SHA-256. However, these algorithms have different capabilities, and faster hash function may provide weaker security in exchange for information improvements. For example, here you can see bars with time required to break of encrypted simple password encrypted with different algorithms. So you can see that password encrypted with SHA-256 can be broken with during 11 seconds running on GPU-enabled computers. But some advanced algorithms require more than 3 years to be broken. Transaction, it's the smallest unit of work processing resulting in the state change of the system or process. So for medical, for example, electronic health record system, such as registration at front office in the hospital or clinic, making an appointment, getting prescription, it's all kind of transactions. Merkle tree, here you can see, is a structure that allows for efficient and secure verification of content in a large body of data. And it's structured like this. Block is a structural data consisting of block data, also called block body, and block header. Block header has a link to the previous block hash, timestamp, and other information. Here you can see an example of real block generated on this blockchain platform. So you can see timestamp and type of consensus algorithms, for example, proof of work. And block body includes information about transactions, so you can see an entire history of all transactions, just exploring block body information. And blockchain, it's very simple. It's a chain of blocks. To add new block in chain, most of blockchains use consensus mechanism, but not all of them. So one review paper conducted 2 years ago identified 66 different consensus mechanisms. So some mechanisms are applied only to public blockchains and they indicated by red color, and some mechanisms are useful for private or consortium. It means permissioned blockchains indicated by green color. One of the most recent paper written this year identified 130 consensus mechanisms. And it's important to review them, so we're able to find several consensus mechanisms such as proof of authority, BFT smart, which means Byzantine fault tolerance, and other which are suitable for big data applications. Smart contract is a computer program in the system when outcome of any execution of the program is recorded in the distributed ledger. Here is an example of smart contract implemented at Oracle platform. They have also blockchain service, and this program written on high-level languages, programming languages, and program simple rules such, for example, if, else, if transaction satisfies certain criteria, it's added to the ledger. If not, it's not added. And here is a simple blockchain system architecture to explain how it works. In some consensus, when nodes agree, not necessarily all nodes, some of them can agree, there are different consensus. The block is created, validated, confirmed, and added to the ledger. So you can see that every virtual machine has a ledger with blockchain. So if something happened here, nothing happened with others. And they are all cryptographically hashed. Information, you cannot change anything. And because, as you saw, even small change, you would see the changes in hashes significantly. And here is a real example of blockchain system architecture, which was implemented by an Australian company for storage of electronic health records on mobile cloud environments using Amazon Cloud to enable possibility for healthcare providers to access data from a cloud using mobile technologies, which is very important. This blockchain used Ethereum blockchain framework and can work in real data with recording all transactions. And the last portion, but most important, about information security. So first of all, blockchain is not automatically more secure than entire system security. So, like, for example, you have distributed ledger technology platform, and it must have basic information security, including identity access management. Here, image taken from presentation delivered by Google Cloud providers. They use very simple approach and measures for information security on Google Cloud platform. So first you need to identify who is on platform, what they can do, which resources they can access, storage or computational, or under which condition, for example, what time, from which IP address, and etc. And the values of blockchain on top of security, which we have with the network or cloud, blockchains adds capability of decentralization, transparency, immutability. So you cannot change records, for example, medical record, who did vaccination or who didn't. Auditability, so you can verify full history, and integrity. And the most important thing that blockchain helps to automate entire process of records and their storage. Thank you for your attention. Please ask any questions if you have.
Thank you, Igor. Have you question? Anybody?
Not a question, just a comment. Igor, nice to see you after so many years abroad. It's interesting that you are speaking about blockchain now, not on remote sensing data processing. Are you still working with remote sensing data?
Absolutely. I'm working, I would say, significant part of my time on remote sensing, synthetic aperture radar, optical data, and developing algorithms for automated processing and designing systems related to remote sensing, variety of aspects. And blockchain, it's one of a project which we recently received, and we're a project-based organization doing research, and for me it was just interesting to learn about something new. But you're right, my major focus is remote sensing.
Okay, thank you. Okay, nice to hear you.
Thank you, and I'm very glad to see you too.
Thank you, Igor. And I see that all questions going not about blockchain, about your persons, because it's very interesting changing. As far as I remember, your basic topics was image analysis and frequency analysis. And are you use frequency analysis for blockchain or not?
Well, blockchain, it's a system just to allow immutable data storage and adds a sort of integrity in your data management, I would say. For other topics, for example, right now I just finished a project using deep learning for identification and detection and segmentation different targets in very high resolution optical images. Another project was about using synthetic aperture radar for soil moisture estimation for some wetlands projects. So we have very diverse portfolio, and blockchain would be helpful to store all results, data, and many other applications. So it's like a bonus for us.
Okay, thank you.
Yeah, Igor, actually, so I'd like to also to add, say many thanks that you was with us after the Thursday sessions. Yes, during our virtual drink party. Yes, it was nice talk with you, and on that talk. So you said that you also quite familiar with remote sensing still and humidity. Yes, and so you also have this project. So now it's also current of your fields, current fields of your research.
Yes, we're doing many different interesting projects here, and some of them, I would say, help to even publish results. And in Canada, for example, very important that it has a very large area and especially some north, it's covered by sea ice, and land is used actively for agriculture, so we need to know about different, I would say, environment conditions, so we use remote sensing for monitoring of this.
So you're quite familiar and similar with us. So it means that the aim of the conference means to re-establish the context which were lost now. So it is actually there is we have a good chance to reinforce our cooperation, find the synergy between our institutions currently where you are. Yep.
Yeah, I'm really glad that I had a chance to do and defend my PhD thesis at UAP, and it's really great institution with very great and brilliant people, and I remember all of you, so I really like it, and I always enjoyed what you're doing at a high level of expertise, and look at your results. You have so many different achievements, so I'm so glad.
Yeah, thank you.
Thank you, Igor. Of course, we can talk about it very, very long time because it is nostalgia. But now we should go, and I should represent that our next report. It is Mikalai, Yatskou, and Vladimir Apanasovich. The title of report is digital platforms for processing fluorescence spectroscopy data using simulation modeling and machine learning algorithm. It's listen very interesting. Let's go. Are you ready? Please start. We don't listen to you, sorry.
So excuse me, probably you're muted, or probably your mic is not working properly. Please check your microphone and start again, because now we can't see your screen also. No, the same. Unfortunately, we can't hear you.
Now can you hear me?
Yes, now is okay.
Okay, that's good. Just a few seconds, I will switch on my presentation. Okay, good day to everybody. I would like to send you my best regards for organizing committee and chairman for nice introduction, and glad to see you all and all your beautiful talks. Now I would like to introduce myself. My name is Mikalai Yatskou. I represent Department of System Analysis and Computer Modeling of Belarusian State University, and today's talk will be devoted to a digital platform for processing fluorescence spectroscopy data using simulation modeling and machine learning algorithms. So I start from a brief introduction to the area of research, and it's devoted to fluorescence spectroscopy data analysis. So experimental fluorescence spectroscopy methods I applied to study the optical properties of molecular systems, such as artificial photonic materials, for example, realized in organic solar cells, also important properties of complexes, protein complexes, biopolymers, DNA sequencing, biological membrane studies, cell and tissues, and also in medical diagnosis. Nowadays, recent fluorescence spectroscopy and microscopy experimental equipment and techniques are developed and widely used. Among them, I can mention many of them. You can see here the abbreviations like fluorescence lifetime image microscopy, fluorescence FRAP, fluorescence recovery after photo bleaching, fluorescent correlation spectroscopy, and so on. What is important, all these high throughput techniques allow to obtain big data which characterize high spectral time and space resolutions. And this data should be analyzed with data analysis techniques. The existing data analysis approach to processing fluorescence spectroscopy data can be divided into classical and modern approach. Classical approach, they use independent or joint analysis of data sets. Among them, I can mention such methods as deconvolution, least squares, maximum likelihood, Bayesian analysis, target analysis, global analysis, and modern machine learning algorithms which are applied are projection transformation, for example, like famous known method phasor, or machine learning parameter estimation, which is made usually through the neural networks, or classification of cell images by machine learning algorithms. These algorithms, they're quite good, but they have some disadvantages, like they do not use physical models, or they use multi-exponential or polynomial decompositions. They may be not precise in parameter estimation when analyzing noisy data, or time-consuming. They need quite big computational resources, or test data sets like neural networks and so on. Moreover, there are no good software tools for realization of this method facilities in one unique form. So the urgent task is to create the computational approach which will improve the analysis and remove the drawbacks of this algorithm. So such approach was proposed in the recent article, and it's a computational approach for processing large sets of time-resolved fluorescent data using simulation model and data mining algorithms. By this methodology, it's possible to increase the accuracy of estimated parameters of physical models. So the two unique things in this approach: the first one is using simulation model, and second one is using machine learning approach. On this slide, you can see the diagram of the developed approach. So we make a set of measurements where we obtained a big data, and in parallel we use simulation modeling, which is unique tool when analytical models are hardly to achieve, or they are too complex to be applied to the analysis of the systems. And machine learning is used for data reduction, for pattern recognition, and most informative data. Then it's used for parameter estimation and giving the physical meaning of with these models, with real models, and interpretation of studied systems. So the whole process of data analysis can be iterative, with following improvements on the model formalism or detailization, or including new mechanism of processes. For example, on this slide, you can see simulation model of energy transfer molecular system of donor and acceptor molecules, which shows the principles of simulation modeling. So laser source excites donor, which emits radiatively a photon of energy, or non-radiatively transfer excitation energy to acceptor. And at multi-channel analyzer, we can record the time of photon arrival, which then is histogrammed, and this histogram reflects the fluorescence decay curve. And set set of equations for this simple system can be shown on this slide. So, in other words, making quite using a priori principles with simple understanding of processes which we can consider in biophysical research and in molecular system, we can imitate quite deep behavior of study system. This is a unique thing in this approach. So I would like to say that many software packages are developed for fluorescent data analysis, but there is none that includes analysis with simulation modeling and machine learning techniques in this area, and they are not universal or dedicated for these things. Therefore, the goal of this work is development of the conception of digital software platform for simulation model and machine learning analysis of fluorescence spectroscopy data. To develop such digital platform, we should take in account some principles. So this should be a kind of programming environment where we can realize simulation model, machine learning algorithm, the coding facilities for analysis, quality assessment, data visualization, code debugging, and so on. If we consider the market, we can see the proper tools for machine learning. I can mention like Veka, Tanagra, RapidMiner, Knime, Orange, Java, and so on. Among them, I would like to mention special platform like Scala, Python, and R platform, which are devoted for this type of things. And of course, Scala projects, they are big industrial project. Python, they are more for engineering and neural net applications, and R platform, on which we are concentrated in our research. The main advantages of a statistical program using environment R is following. It has optimized structures for representing data objects, optimization of programming tools, implementation of computational algorithms, a huge set of libraries developed by scientific community, and possibility to make so-called reactive web interfaces using Shiny packages. Thus, we develop as a base for the digital platform the programming environment and Shiny package. On this slide, you can see the flowchart of digital platform that can integrate the research scheme for a certain biophysical process, and it contains of several stages, like loading data, first stage, the second is simulation modeling, then third, clustering. Fourth is dimension reduction, in which we utilize the principal component analysis, then fitting by physical models and visualization of results. As demonstrative example of the conception of digital platform, we realized digital platform methodology in a computational platform Fluorescence Studio, which is devoted to processing fluorescence kinetic curves obtained in fluorescence lifetime image microscopy experiments. The web application of our development is available on the server. You can see the link to this web page. I briefly show how it works. You can download your data, or you can simulate your data. On the left panel, you see the data loading. On right panel, you can see the data simulation, where you can select the models and model parameters. Then having big data, we can make clustering and select the most representative data from these clusters. In following usage of data reduction technique like principal component analysis, we can see our data in reduced space. We can find the centers of these clusters. So one dot is one time kinetic fluorescent decay of our sample. So we can select most informative data and then analyzed in more detail with physical models which are proposed for analysis. You can see the fitting of the fluorescent decay curves and obtaining physical parameters with possibility to export data and results. And bookmark with demonstrating results of the analysis. You can see on the left side the picture of fluorescent decay curves in a space of first three principal components and original space. As you can see, we were able to nicely identify fluorescent decay curves corresponding to different molecular species and estimate their parameters. So I would like to finalize my talk and say that the conception of digital platform for processing fluorescence spectroscopy data has been developed, and integrated machine learning data analysis pipeline enhances the efficiency of biophysical research. This digital platform allows to model and analyze a large experimental fluorescent spectroscopy data. Proposed methodology is realized as a digital platform Fluorescence Studio for analysis of fluorescent kinetic curves, and digital platform can be extended by including novel machine learning models and algorithms as well as simulation models. So thank you for your kind attention. I'm ready to answer your questions.
Thank you for your report. It's really interesting software, but I have a question. What's the basic application of this software? Where you use it in the enterprise and something like that?
So this application is acceptable online, and all research community can use it. It's for free. It's dedicated to analysis of time resolved fluorescence spectroscopy data. It means that specialists from area of fluorescence spectroscopy research all over the world can go to this webpage and can analyze. So they can upload their data. They can make analysis with models which are available now online, or may develop new models. With these new models, you can analyze physical process or molecular system and then extract the information in biophysical research. Yes.
Okay, thank you. Maybe anybody have...
Sorry, I have one question.
Yes, please.
So very interesting talk. So right now there is like a philosophical trend for some researchers and many researchers to replace physical-based models with deep learning approach. So when they train models, sometimes they achieve very magnificent results. You can see some features which with physics is very difficult to resolve. So did you have a chance to compare your approach with some advanced deep learning based on CNN's network results? Thank you.
Yeah, thank you. Very good question. The idea, so the using of recent machine learning approach like deep learning neural networks, it's mainly solving question of a kind of classification or prediction, so-called not going to physical meaning. Yeah, in our approach we have a little bit different direction. We would like to take physics. Yeah, so our goal is not only to show the tendency, yeah, or classification, but also to take physics. For this, we need to use physical models. Yeah, so in this case, we try to distinguish more information, and moreover, with our physical models, we can train machine learning techniques, neural networks. We can train, we can create data sets which can improve the prediction ability of neural networks. I would say the main reasons why we use the simulation modeling and in cooperation with machine learning algorithms is just to take more, to study more knowledge or hidden knowledge from the data. Yes.
Okay, I'd like also to ask a question. Thank you very much for very interesting presentation. I would like to ask you, you are working with spectroscopy data, not images, right? So you do not have input images, or you have
We don't analyze directly images. We have image in one a kind of dot or unit. We have spectrum, fluorescent decay curves, and so on. So the information from image can be taken in account while the analysis. But in this talk, I'm speaking about time resolved data, not for the images.
But when you do this clusterization of data, you just everything you are doing based on spectroscopy data, right?
Yes.
And you do not then use this data in some way to match to input images possible for this data, or you do?
No, I do not do this, but there are in literature a number of publications where research groups try to include information from images like localization area and to make more to increase the power of prediction. Yeah. Mm-hmm. Yeah, so it can be also extended. And in my slides where I show this dots and were just spectroscopy data. So not in today talk. So its images are not considered, but they can be included. They can be included.
But you work also with images, not only with spectroscopy data, but also with images.
At this moment, I don't work. I work just with spectroscopy data.
Okay, thank you very much. Mm-hmm.
Thank you for your nice question. Yeah.
Thank you.
May I ask some stupid question? Is this you are dealing with which frequency of this spectroscopy you have in mind and your software? Or this is somehow universal, flexible software?
It's quite universal. So I would say you can consider different diapasons of spectral measurements, and as I mentioned in my first slides, I consider fluorescence lifetime image microscopy, and on the samples which are usually measured at this wavelengths.
Is this really possible?
Between 300 and 800 nanometers. Yes.
For instance, there was a presentation from Bochum about the infrared spectroscopy, multispectral images.
Yeah.
So, do you think it's possible to use that tools you reported for that problem?
Yes, surely it can be used. There is also our colleague Achim Koller, who works in similar approach. He uses principal component analysis to make a distinction between different types of samples, and it can be also applied in this area. Yeah, sure.
Okay, they got further. They're not using just PCA now. They're using three-dimensional neural networks when they have X, Y, something like 1000 by 1000 and 400 in depth, which is the spectra in every pixel. So everything is going on quickly. Okay. Anyway, thank you very much. It's a good. I'm proud that you are also using R because I'm something like lost here with this. I installed that recent software on deep learning under R platform, but everyone pushed me to Python. Okay, anyway, that's technical thing. Thank you very much.
Thank you.
Thank you all. It was our last report. I'm glad that this report from Belarusian State University, because it is the famous university in Belarus. And now we finish.
Yeah, thank you, Alexander. Basically, yes, we have now the last presentation of our current session, and I'm afraid that we also have not one presentation from the next session. So what I'd like to suggest is just to be with our plan. So we will come back on 3 p.m. Minsk time zone. And then we will have just only 4 presentation, and immediately after this we will close our conference. So now I'm just suggesting you not to disconnect and come back for the last session and closing of the event. Thank you. Now we have a break.